Okay, class, today we're going to be talking about a familiar topic, but we're going to be introducing new things. And the familiar topic is the topic of circles. Okay, and in order to talk about circles, we need to come up with some definitions. And so the definitions is very important that you print out the notes on page 153 because this vocabulary is new, so you need to know what these mean. And I've added drawings to add to your understanding of the concept. So we all know that circles have a radius and they have a center. But there's also some line segments of circles, and we're going to take a look at a few. But before we do that, we're going to talk about the parts of the circle. We know that the entire distance around the circle is called a circumference, but pieces of the circumference are called arcs. And arcs are defined by endpoints on a circle. And as we can see here, in this particular circle, we have two endpoints A and B. And they define two types of arcs. They define an arc which is minor, which means it is a part of a circle where the measure of this is less than 180 degrees. And I know some of you may be saying, I didn't know that was an angle. There is an angle that produces that arc. This angle right here. So if that angle is less than 180 degrees, then that's a minor arc. But if that angle is more than 180 degrees, then it's a major arc. This is a major arc, while the one in green is a minor arc, because the angle that produces this arc is less than 180 degrees, and the angle that produces this arc is greater than 180 degrees. And this particular arc, which measures not the whole circumference of a circle, but half of it, is called a semicircle. And in a semicircle, the arc that produces it, or the angle that produces it, is actually a 180-degree angle. And so that's why we call that a semicircle. And in each arc, there are differences in line segments. So let's take a look at. Now, when people talk about measuring an arc, they're talking about not the length of the arc or the piece of the circumference. They're actually talking about the angle that produced that arc. So the measure of this minor arc is this angle. The measure of this major arc is this angle. And the measure of this semicircle is this angle. So it's important that we notice the difference. So the measure of the minor arc is the measure of the angle that produced that arc. And the measure of the major arc is a measure of the angle that produced that arc. But the difference between these two numbers is that their sum should be 360. Okay? And circles are congruent if they have the same radius, and their arcs are congruent if they have the same measure. So these are the notes that you didn't know about. So let's take a look at this theorem right here. So here we have the measure of arc AB. So here is arc AB, and the measure of arc AB is 50 degrees because a 50-degree angle produced that. Whereas the measure of arc ADB, which is the major arc, starts at A, goes through D, and ends up at B, is 310 degrees. And I know you're saying, how did you get 310 degrees? Well, remember, the measure of the entire circle is 360 degrees. And the measure of the major arc is going to be the difference between the 360 degrees and the measure of the minor arc. So if I take 360 degrees and subtract 50 degrees, I'll get 310. And of course, the measure of a semicircle is 180. So we have one more proposition, which is kind of very much similar to when we did line segments at the beginning of the school year, which is the measure of an arc. So here we have an arc that starts at A, goes to B, and goes all the way to C. Well, one way that we can measure it up is by breaking that arc up into two pieces. One piece is from A to B, and the other piece is from B to C. And again, when we talk about the measure of the arc, we're talking about the measure of the angles that produce these arcs. So the measure of AB, angle A, center B, the measure of angle B, center C. And we add up those angle measurements, we'll be able to see that the entire angle measurement is a measure of this arc. So what goes here are the measure of the angles that produce those two arcs. Okay, let's take a look at the next page. Now we're going to talk about line segments of a circle. So we know the distance of a circle, and we know the definition of circle, center, and radius. That's nothing new, but on page 151 are some new words that you may or may not remember us using. And I'm going to show you that the picture is so much better than the description. In this case, we have this picture. And here we have a circle, and it says a chord is a segment whose endpoints are on the circle. So an example of a chord in this case would be DE and AB, because the endpoints of this line segment are on the circle. So those are chords. Then it talks about a diameter. Now a diameter is a chord that goes through the center of the circle. So a diameter would be, in this case, AB, because it's a chord that goes through the center of the circle. Then it talks about secant, and the secant is a chord that intersects the circle in 2 points. So if I were to extend each of these lines out, whether they be through the diameter, or through the center or not, then those would be secant lines, because they go through the circle and they intersect the circle twice. So those are secant lines. And a tangent line is a line that only intersects the circle once. So to draw an example, we don't have one on this picture, but to draw an example, it looks something like this. And I want to use a different line color because I don't want you to think it's the same type. So let me change it to this type of chord. So here the chord does not go through this, the tangent line does not go through the circle. It touches the circle in one spot, and so that's why we call this a tangent line. Okay, so there are some theorems that we want to look at, which is number 1, if a line is tangent to a circle, then that means it forms what type of angle with a radius of the circle. And if you said perpendicular, you're absolutely right. So the tangent line is going to be perpendicular to the radius, to a radius. And then if 2 tangent lines intersect outside the circle, then the external point this is the external point S, to the point where it's tangent on the circle is the same distance as the external point, the intersection point, to the tangent point on the other circle. So these two are the same length. All right, that's it for the video.